the expressions involving these different kinds of radicals or rational exponents. Today we're going to kind of set that on the back burner and kind of move forward a little bit and start talking about solving. And mostly what we'll do today is just kind of look at some examples of specific situations, kind of talk about like what are some of the tricky things we have to watch out for when we're doing solving, and look at some of the different kinds of solving situations we'll kind of run into. So we'll really just be looking at a series of example problems here today. There's not a bunch of like new or theoretical information or anything going on there. It's just kind of largely just kind of talking through some of these different solving scenarios and what are the kind of the strategy or the things to kind of watch out for. Okay? All right, so let's just blow through a couple of examples here. So here's a solving equation problem where we have a square root in it. In general, for all of these problems we're going to talk about today, the general strategy is going to be to isolate the radical part and then to cancel that radical part or cancel the radical out and then finish solving from there. So here, the first step we'd want to do to isolate the radical is to get rid of the minus 6 going on. Bless you. So we'll start by just adding 6 to both sides. The next thing we need to do is to cancel out the times 2. So to cancel that out, we'll divide both sides by 2. And now that the radical is by itself, now we can worry about canceling out the radical symbol. So to cancel out a square root, we're going to use an exponent. The exponent that we'll use is 2. So we'll square both sides to cancel out the square root. So the squared cancels the square root. And then 8 squared is just 64. And then we'll subtract 4 from both sides to finish it out. So far, so good. Okay. So that wasn't too bad, I hope, right? That should feel pretty natural and very similar to things that we've done already. Let's do that. Okay. So similar problem here, right? Looks almost the same as the previous one, except instead of looking at a square root, this one is a cube root. That doesn't really matter to us, though, at least initially. We're still going to start the same way. We're going to want to isolate the radical part first. So we'll subtract 4 from both sides. And then divide both sides by 2. And then to cancel the cube root, what exponent should we use? 3, right? Cubing both sides is going to cancel out the cube root. And then -1 to the third is just -1 times -1 times -1, which is still just -1. So just to reiterate that I did do something there, just turns out that -1 and -1 to the third are the same. And now I can go ahead and finish solving this up now that the radical part is gone. So subtract 3 and then divide by -2. And there we go. So at this point, everything seems really pretty straightforward and like should feel quite comfortable. I want to point out to you guys, though, some other things can happen here in doing these problems that maybe is not quite so clear. So let's say we have this problem, right? Looks almost identical to the first one we looked at. Right? Doesn't seem like there's much different. Although this one, something decidedly different is going to happen. So, but again, looks identical. We'd start it the same way. So we'll subtract 6 and then isolate the radical part. And then just like before, to cancel out the radical, we'll square both sides. And then finish her up by just subtracting 5 from both sides. So x equals -4 should be our answer. Here's the problem, though. If we go and we check that, so if we plug -4 in, so -4 plus 5 is 1. The square root of 1 is just 1, and 1 times 2 is 2. And 2 plus 6 is definitely not 4, right? So here we have an extraneous solution, right? That's when we solve a problem correctly, but the solution we get at the end doesn't actually satisfy the equation. So we got to make sure that we're checking these problems because the extraneous solutions can kind of start popping up. So maybe it's not quite as straightforward as it initially felt because this little tricky thing can happen. Landon?
Is there a way to identify other than just checking, or is it really just check it?
So there's some ways that you can use to identify rather than checking, but not all of them always, like it's not always, in not all the situations can you do that, but there are some situations where I could have, this problem, there was an point obvious that this was going to have no solution during the solving process, specifically at this step. So here we have that a square root is equal to -1. Can a square root give us a negative number? No, right? So right there I could have told, I would have known exactly that, okay, so this one should have no solution. Any answer I get out of this is going to be extraneous because that's a nonsense statement. Now, I want to point out to you, though, similar thing happened here in the previous example. But this one, I didn't stop and check it and point out that it was extraneous because it's not. Why is it okay here? What?
The negative one stays in there.
Well, it's not so much that. What kind of radical is this? This is a cube root, right, in this problem? Can cube roots give us negative numbers? Yes. So here, we don't even need to worry about checking for the cube root problems. Those ones can never give us an extraneous solution, so that helps a little bit. The square root, or any really, and even if we want to extend that further, like odd root problems, we don't need to check for extraneous, but even root problems we do. Now, when we check the even roots, really we're plugging it back into the original part to check. But you might be able to find some other places along the way that like, oh, look at this, square root gives me a negative, like that can't happen. But not every one of the problems will that be a possibility. But certainly that's, you could use that in addition. And then just to point out to us here in the very first one we looked at, here at this step we have a square root equaling a positive, which is good, right? That can happen. Everybody's okay with that? So this is like the easiest type of problem here, are these ones that just have like the square root and the cube root with just an x in a single location like this. So another type of problem that we're going to look at okay. So if you guys remember from before break, we had talked about how these fractional exponents are really the same thing as a radical. Right? So here we're going to just kind of approach this the same way, where we'll want to start by isolating the piece with the rational exponent attached to it. So the same way we had done before. So we'll subtract 2 from both sides. Both sides by 4. And now what I need to do is cancel that exponent of 3 over 2, right? What exponent is going to cancel a 3 over 2? So remember, when I have an exponent of an exponent, I multiply, right? So the exponent I want in this case is going to be 2/3, because I know if I multiply a fraction and it's reciprocal, they cancel. Everybody's okay with that idea? Okay. So here we're left with x equals 8 to the 2/3. And now that's a problem that looks a lot like something we would have done before break. So to simplify that, I'll just do a prime factorization on my 8, leaving me with an exponent of an exponent. So we'll multiply those two exponents. That gives me 6 over 3, which reduces down to 2. So I get that x is equal to 4. And then to check this, we have 4x to the 3 over 2 plus 2 equals 34. Let's write that in a different color, huh? So if I type in 4 to the 3 over 2 into my calculator, I just get 8. Or you could do it by hand. And that gives me 32 plus 2 is equal to 34. And that's true. So this isn't extraneous. So that okay there? So not much different than the previous problem, right? Still felt like the same kind of pattern. E, I think, is the letter we're on then. No, I want that to be there. Okay. So again, very similar. So this is the piece with the fractional exponent attached to it. So we're going to start by isolating that piece, just like we had done in the previous problems. So add 6 to both sides. And then divide both sides by 2. And then to cancel out the exponent 2/5, what exponent should I use? 5 over 2, yep, or 5/2, yep, that's good. And when I type in 4 to the 5/2 into my calculator, or you could do it by hand, either one, is you get 32. But this isn't quite right, so we forgot something here. Does anybody notice what it is that we forgot? It's very subtle here. It's easy to overlook this. So when we did this exponent of 5/2 to both sides, what does the 2 in the denominator of that exponent really mean? It's really the same thing as a square root, right? The square root was the same thing as an exponent of 1/2. So if the denominator of my exponent is a 2, we're doing a square root. We're doing some other stuff with it, but we're definitely square rooting both sides, right? So because of that, when we square root both sides of an equation, we know that we also need to include a plus or minus, right? Remember that from previous chapters? And you might be saying to yourself, well, Mr. Kulik, we did that just a minute ago in the previous problem, and we didn't have to worry about a plus or minus. And I would say, well, not exactly, because there my denominator in the exponent is a 3. That's a cube root, which doesn't generate a plus or minus when we do that. So just note, if you do some exponent to both sides, if that denominator is an even number, you need to include a plus or minus. Otherwise, you don't. Everybody so far so good? Okay, we still have that problem to finish up. Let's go back. What I would do at this point is break this now into two equations. One with the positive 32 and one with the negative 32. And just solve each of them separately. So negative 14 for one solution. Oops. And then negative 18 for the other. And then going back to the original problem, notice that the denominator here is a 5, which is like a fifth root. So there's an odd root problem. So does that mean I should have to check this? I do not. Now, if you check it, that's fine, no big deal. You should get that these answers both work. It's not wrong if you check them all, but on the odd root ones, you can skip the checking. You don't have to do it there because it won't ever be extraneous. But it's not wrong to just check them all. You know what I mean, Lily? Oh, positive 18. Thanks. That feel okay with you guys? All right. On F, I think. Okay, a couple more examples and we'll call it quits for today. So here's another example. Now this one is decidedly different than any of the problems we've looked at so far. What is the piece that's really separates this from any of the other examples that we've looked at to this point? What characteristic? Landon? Yeah, in fact, we have x's in different places, right? We have an x under a radical and an x not under a radical. This is going to be the most difficult scenario that we're going to cover in this course for these types of problems. But it doesn't really change the procedure that we're going to use. So we're still going to want to start by isolating the radical. So in this part, or this problem, the radical is already by itself on the left-hand side, right? So there's nothing really to do to isolate the radical. So we'll then want to cancel the radical out. So to cancel that square root, we're going to square both sides. So the square cancels the square root. And then I have x plus 2 squared. That means we have x plus 2 times x plus 2. Got to be real careful there. It's very easy to forget to FOIL on that, but you need to make sure that you do. If you do not FOIL and you just distribute that exponent, you will get the wrong result. So be very careful there. It's easy to make that mistake. Notice this time, though, the problem that we're left with is not a linear equation, but rather it's a quadratic equation. To solve a quadratic equation, the first thing I'd want to do is get it equal to 0. This is what makes this maybe the hardest of the types we've looked at so far, is that you end up with these quadratic equations often. You don't have to end up with a quadratic, but more often than not, you probably will. So we're left with 0 equals x squared plus 2. Remember, to solve a quadratic with 3 major approaches, you could solve it by factoring, you could solve using the quadratic formula, or you could solve directly, just using a radical or whatever. Of those 3, which one of them seems most appropriate in this situation? Or easiest in this situation? I would just solve this directly because I have only x squareds and no x's. So I can just, oh, boogers. I want to do this here, guys. Jeepers creepers, almost made a big mistake there. Okay, so to solve this directly, I can just add 2 to both sides. And then square root both sides. Is that okay with you guys? But I'm not finished. Still need to check. I'm going to do that checking, though, just on my calculator, since my answer is the square root of 2. That's like, I don't want to plug that. It's just not going to work out very nice, right? Like I'm going to use my calculator and look at the decimal. So I'll have the square root of 4 times the square root of 2 plus 6 and then the square root of 2 plus 2. So that works. So one answer is correct, right? Then I'm just going to go ahead and do the same thing, just with the negative square root of 2. And let's see what we get there. The same. So both of those worked. So I will both of those solutions. Everybody cool there? Let's do another. That work. Okay. So another example here. So very similar to the previous one, right? Now we'll start the same way. So we'd want to start by isolating the radical. Here there is some work to do to isolate the radical though, right? I'd want to start by subtracting 2 from both sides. Now that the radical is isolated, Now I can cancel it out by squaring both sides. Remember, for the x plus 3, we have to FOIL. So I'm not going to write out the double parenthesis there. I'm just going to make a note that I FOILed and write out the FOILed answer. Again, if you have to FOIL that stuff by hand, that's totally fine. No big deal. I just don't want to show that much work. We're just going to kind of talk about it, what I did, and then move on. I think that's a skill you guys should be pretty comfortable with. So we're left with this quadratic equation that we're going to move everything onto one side. So to solve this quadratic, again, we could try factoring, quadratic formula, solving directly. Which one of those three would be the best choice in this situation? Landon?
Quadratic.
You could use the quadratic formula. I would actually try to factor this first. Since the leading coefficient is 1, if it's factorable, I should be able to find it pretty quickly, and that might be faster than the quadratic formula, although that is certainly correct and will work. I just think that factoring in this case might be a little bit quicker, assuming you remember how to do it. And if you didn't, then the quadratic formula certainly is the better choice there. So I would be looking to multiply to get -4 and add to get 3. -1 and +4. Exactly right. So x minus 1 and x plus 4. So I can set each of those equal to 0 then. So I get +1 and -4 as my solutions, which again, may be a little bit faster than the quadratic formula, but it would have given you the same result. You know, not a big deal, or not a big difference. We have to check this though still. So again, I'm just going to use the calculator to handle that for me. So when I plug +1 in, I get 4 for one side and 6 for the other. Well, that's not good. So that solution doesn't hold. Let's see if -4 works. That one did work. So here, one of the solutions is extraneous and the other is not. And that certainly can happen, right? In any of these situations, everything could be extraneous. Some of it could be extraneous, or none of it could be extraneous. So that can certainly happen if you have in any of these situations. So that's, I think, is the most difficult situation that I want to deal with for this class, for the solving parts. And that feels like probably enough to do on our first day back from break. So for your guys' assignment, I'd like you to do this homework 6 that I have in the content library. This is my updated version. So there's 22 of these problems to try. And then we'll take questions and stuff next time and all that. You guys can spend the remaining 30 or 40 minutes here we have left in class starting on this, which is nice to get a big jump on it for a process that, again, shouldn't be too bad, but like there's some tricky stuff going on that can kind of, you know, trip us up a little bit, which is good to be able to start in class and get some immediate feedback on. Okay?